Hi again. In this video, we're going to look at solving rational equations. Now, with rational equations, these are simply equations that include rational expressions. And we have a little bit more flexibility when we have an equation because we are allowed to perform operations on both sides. So when we added and subtracted rational expressions in the previous video, we had to find a common denominator. And that meant changing the denominators of different expressions. Here we won't have to do that, but we still have to keep track of those values that have to be excluded from the denominators. Let's take a look at this first example. We have x over x minus 1 plus 2 over x minus 3 equals x squared over x squared minus 4x plus 3. All right. So what we'll want to do is we will want to multiply both sides by something that clears the denominators. And for that, we need to see what factors of the denominators live over here. So we've got an x minus 1, okay, an x minus 3, fine. And what does this factor into? So let's find out. So we have x over x minus 1 plus 2 over x minus 3 equals x squared over, and then we'll factor this. So we have x minus 3, x minus 1. All right. So here we note that x cannot be 1 and x cannot be 3. Okay, at this point we can go ahead and multiply both sides by something that clears all of the denominators. And so whatever we multiply has to have a factor of x minus 1, x minus 3, and the product of the two. And that ends up being just the product of these two. So we'll multiply both sides by that. So we'll multiply by x minus 3 times x minus 1, and then all of this by the same thing. Let's go ahead and squeeze that in here. X minus 3 times x minus 1. Okay, so I'll include the domain restriction up here. So x cannot be 1, x cannot be 3. Okay, over here, we've got x minus 3, x minus 1 over x minus 3, x minus 1. Those are going to cancel, leave us with x squared. Okay, over here, we're going to multiply into each term. So this term into here, and these x minus 1 factors will cancel. Leaves us with x minus 3 times x. That's x squared minus 3x. If we multiply it out. Okay, these two terms go into this term, so the x minus 3's will cancel. We're left with x minus 1 times 2. That's plus 2x minus 2. All right, and you can see now that the result of clearing the denominators leaves us with a quadratic equation. And we can simplify this. So let's subtract the x squared. We've got minus 3x plus 2x. So that's just negative x minus 2 equals 0. And that means negative x equals 2 or x equals negative 2. All right, now negative 2 is not a value excluded from our domain, so this is going to be our solution. All right, let's look at another example. So negative 3x over 2 equals negative 4x over 3 minus 2 over 3. This is similar to what we might have if we had a bunch of fractions with natural number denominators instead of polynomials. Our approach doesn't change. We want to clear all the denominators. We've got 3 and 3 and 2. So we need to multiply something that would clear them all at the same time. And that's going to be 3 times 2, or 6. So let's multiply both sides by 6. If we multiply by 6, we get negative 18x over 2. That's negative 9 x. 6 into here gives us 2. 2 times 4 is 8, so negative 8x. And then minus 6 divided by 3 is 2, times 2 is negative 4. All right, we can add the 8x to get negative x equals negative 4. That means x is 4. Note there's no variable in the denominator, so we don't have to worry about any domain restrictions for this. X equals 4. Okay, let's do a couple more examples. Here we have 2 over y minus 3 equals 3 over y plus 2 plus 1. All right, first off, we'll note that y cannot be 3. Y cannot be negative 2. All right, once we've got that down, we can go ahead and multiply both sides by something that clears all of the denominators. In this case, we want it to be the product of both of these. 1, the denominator of that is just 1, so we don't have to worry about that. Okay, so let's multiply both sides by y minus 3, y plus 2, y plus 2. This side over here. Y minus 3 times y plus 2. Okay, and now we will distribute those in. So y minus 3 divided by y minus 3, those are going to go away. And we take y plus 2 times 2. So that's 2y plus 4 equals. Over here, we want to multiply this into this first term, so the y plus 2's go away. We have 3 times y minus 3. That's 3y minus 9. Now the product of these goes into the 1 here, so plus y minus 3 times y plus 2. All right, this is just a quadratic, and we can solve those using methods that we've talked about before. So we'll have our 2y plus 4 equals 3y minus 9. Multiply this out, plus y squared. Outside, inside would be minus y, last minus 6. All right, simplify this a little bit. 2y plus 4 equals, let's see, we've got y squared. We've got plus 2y minus 15. This is a quadratic, so we want to get everything on one side. So subtract the 2y, subtract the 4. We have 0 equals y squared minus 19. Add the 19. So we get y equals plus or minus square root of 19. All right, let's look at this last example. So we have x cubed minus 8x squared divided by x squared plus 2x minus 80 equals negative 19x minus 90 over x plus 10. All right, so here, let's go ahead and factor this. Make sure we're not multiplying by too much. We need pairs of factors of negative 80 that add up to positive 2. So looks like plus 10 and minus 8. Outside, inside, plus 2. Last, negative 80. Yeah, that works. Okay. And then over here we have negative 19x minus 90 over x plus 10. Okay. So looks like we'll have to exclude x can't be 8, x can't be negative 10. And then to clear all of the denominators, we'll need to multiply by x minus 8 times x plus 10. So x minus 8, x plus 10. Over here also, x minus 8, x plus 10. All right, so this just cancels everything over here. We're left with x cubed minus 8x squared. Let's go ahead and factor out the x squared. Over here, we're left with, let's see, 8x minus 8 times negative 19x minus 90. Right, now, since we've already said that x can't be 8, it's safe to divide these out from both sides. And we'll go ahead and move everything to the left-hand side. So x squared plus 19x plus 90 equals 0. All right, and now we can factor this. So we need pairs of factors of 90 that add up to 19, 10 and 9. So x plus 9, x plus 10 equals 0. So x equals negative 9, x equals negative 10. But we can look at our domain restriction. X cannot be negative 10, so we'll have to exclude that. We're just left with x equals negative 9. Okay, so here's just a few examples of solving rational equations. You'll, of course, want to practice those yourself on your practice before you hit your certify. All right, I will see you in the next video.